welcome to the Deep Dive. We're kicking things off today with, well, a real contradiction, something that really defines modern geopolitical conflict, maybe even challenges how we think about national security altogether.
Which is?
How is it possible that the stuff needed to build, say, the world's most advanced fighter jets, and a really common drug derived from, believe it or not, pig intestines used every single day in surgery? How can both of those things be right at the heart of the biggest geoeconomic fight between the U.S. and China right now?
Yeah, it sounds like a paradox, doesn't it? But it's more than that. It's a serious wake-up call.
How so?
Well, for decades, the economic conflict, it was all out in the open, very public, tariffs, trade quotas, all that stuff.
Right, the headlines we all saw.
Exactly. But what our sources are showing now is a really critical shift. The fight's moved on. It's not just about who sells the most washing machines anymore.
Okay.
It's shifted to who actually controls the foundational resources, the things that underpin, well, pretty much the entire global military and medical infrastructure.
And that is the mission for us today in this deep dive. We want to get past those headlines, really unpack the nitty-gritty details of this new resource war.
It's crucial.
So we're going to look specifically at two, let's call them weapons that China holds. Unique, incredibly powerful weapons.
Which are?
First, the high-tech leverage you get from rare earth metals, REMs. And second, the sort of silent life and death leverage from this anticoagulant drug, heparin.
Two very different things.
Totally different. But we need to understand why the U.S. is so deeply vulnerable on both fronts, high-tech hardware and essential public health, and what this radical, pretty quiet maneuver actually means for global power going forward.
You could think of it like the difference between just a border skirmish and a full-on siege.
A siege.
Yeah, because controlling these inputs, these raw materials, it means you control the destiny of nations, essentially. It's not a debate over market share anymore. It's a battle over who controls the basic ingredients needed for survival, both military survival and, frankly, medical survival.
And we're talking about components, materials that might be relatively cheap to produce in some cases.
Right, relatively cheap. But they become absolutely priceless the moment someone denies them to you.
Okay, let's start by setting the stage. How did we get here? This conflict, it's been simmering for years, right? Mm-hmm. Sanctions, tit-for-tat tariffs, customs duties.
A slow boil, exactly.
Okay.
But the sources we've looked at are really clear on this. China has now basically unveiled its most dangerous set of geoeconomic weapons.
Going beyond just trade disputes.
Way beyond. It's moving the whole confrontation into the realm of resource control, strategic resource control.
And it's important to understand why the old tools, the tariffs and quotas, why they sort of failed, isn't it?
Absolutely crucial, because tariffs, even when they hurt, they're still basically market mechanisms, meaning they drive up costs for consumers. Sure, they might shift manufacturing around a little bit, but ultimately the huge global market tends to absorb them.
Right, like if the U.S. puts a 25% tariff on Chinese steel.
Yeah, the market grumbles, finds slightly more expensive steel somewhere else, maybe Brazil, maybe domestically, or American consumers just end up paying a bit more for their cars or appliances. It's an inconvenience, a pain point, but it's not usually an existential threat.
So those tariffs weren't really delivering the knockout punch, politically or economically?
Not the kind of leverage needed for fundamental change, no. The old conflict was really about price. Who pays more?
And the new battle.
The new battle, and some sources describe it as an intensified battle for survival. It's about existence. Can you even make the thing you need?
Okay, that's a big shift.
It is. China seems to have recognized that controlling strategic resources, the stuff vital for advanced industries, AI, military tech, it creates what economists call an inelastic shock.
Inelastic meaning? No substitute.
Pretty much. If you cut off the supply of, say, a specific rare earth element needed for a missile guidance system, there's no readily available alternative. You can't just pay 10% more for a slightly different element. The manufacturing line just stops. Dead.
Wow. That's a completely different kind of power.
It's fundamental leverage. And the political context here is fascinating, too. We looked at Michael Schumann's analysis in The Atlantic from April 2025.
Right. He talked about both leaders, Trump and Xi Jinping, needing to look strong for their home audiences.
Exactly. Both feel that pressure. But Schumann points out a key difference in how prepared they are for this kind of fight.
And China is.
Schumann's take is that China is prepared. They've calculated this. They're not deterred by threats of more tariffs. precisely because their leadership sees this fight through a different lens.
What lens is that?
Defending national dignity, yes, but also securing long-term strategic control. And crucially, the sources emphasize this. Xi Jinping knows he has specific weapons in his arsenal that the U.S. can't easily replicate.
Like the heparin we mentioned.
Exactly, like the pharmaceutical weapon heparin. Just knowing you have that card to play, that gives you an immense psychological edge in any negotiation.
Yeah, I can see that. It totally changes the dynamic at the negotiating table. If you're arguing about, I don't know, semiconductor quotas,
Right.
but, quietly, that you could potentially halt open heart surgery in the other guy's country just by, restricting a shipment.
You're negotiating from a position of profound, almost hidden superiority. It becomes less about winning a specific trade concession and more about demonstrating your structural dominance over their whole system.
So China isn't just playing defense against U.S. sanctions anymore.
No, it seems they're proactively using their control, their chokehold over these strategic inputs. The message seems to be, if Washington escalates, we won't just slap on another tariff. We'll hit you with targeted, resource-based retaliation that causes immediate systemic failure.
Not just economic inconvenience, but actual breakdown.
That appears to be the threat. Which brings us neatly to the two key vulnerabilities we're focusing on today.
Right. High-tech hardware on one side, essential healthcare on the other.
They sit at opposite ends of the tech spectrum, you could say, but they're equally critical for national security, just in different ways.
So on one side, the rare earth metals, the guts of advanced defense systems, the future tech.
And on the other, the absolute necessity of heparin for day-to-day healthcare. Basic survival, really.
It's like a strategic pincer movement.
It really is. It's the ultimate 1-2 punch, almost designed to maximize pain hitting the infrastructure of advanced warfare and the infrastructure of public health at the same time.
We used to talk about mutually assured destruction through missiles.
And now maybe we're moving towards mutually assured vulnerability through supply chain control. It's a different kind of Cold War, perhaps.
Okay, let's dig into the first weapon, rare earth metals, REMs. This is the more, maybe, flashy, high-tech story. The sources talk about a specific move by Beijing, calling it a calculated and dangerous shock. What exactly did they restrict?
So China announced they were halting, or at least severely restricting, the export of a very specific group of rare earth permanent magnets.
Not the raw materials, but the finished magnets.
Exactly. That's the crucial point. It's not a blanket ban on all 17 rare earth elements. That would be, well, messy and maybe counterproductive. This is surgical. They targeted the finished components.
Why magnets specifically?
Because these specific types of magnets are absolutely indispensable for modern advanced technology.
Okay.
We're talking precision robotics, aerospace components, high-performance electronics, EV motors.
Okay, so these aren't your fridge magnets.
Definitely not. And the restriction targets magnets made using specific heavy rare earths. We have the list: samarium, gadolinium, terbium, dysprosium, lutetium, and scandium.
Right, those 6. Can you explain for listeners why these metals are so critical? What makes them different? Why are they the difference between, say, a modern fighter jet and something you'd find in a museum?
It really comes down to physics, specifically magnetism and heat. When you need magnets for really demanding applications, think inside a jet engine or a missile guidance system or even a high-speed electric vehicle motor, you need 2 things: incredible magnetic strength and the ability to maintain that strength at very high temperatures. Standard iron magnets, even strong neodymium ones, they lose their magnetism, they demagnetize when they get hot.
This happens a lot in engines and high-power electronics.
Precisely. So elements like dysprosium and terbium, maybe gadolinium to some extent, are added to these magnets, particularly neodymium iron boron magnets, specifically to give them that high-temperature resilience, what's called coercivity.
So dysprosium is key for heat resistance.
It's a critical ingredient. Without it, you simply cannot make magnets that are powerful and reliable enough to operate efficiently in the extreme heat environments found in things like an F-35 fighter jet systems, or a cutting-edge wind turbine generator, or even compact, powerful EV motors.
So these aren't just components. They're like the hearts, as the sources say, of these sensitive industries. They enable the miniaturization and power efficiency that defines modern tech.
Absolutely. And the applications go way beyond just military hardware, though that's obviously a huge concern. It's electric vehicle motors, a massive growing market. It's AI systems needing powerful, compact processing. It's even in some advanced smartphone chips.
And critically advanced U.S. military systems, aircraft, missiles, sophisticated defense tech. So the implication is, if China controls these 6 elements and the magnets made from them.
They effectively control whether the U.S. military can build or even upgrade its most advanced arsenal. That's the raw strategic vulnerability.
And the scale of China's dominance here is, well, the numbers are stark.
They're frankly terrifying. This isn't like, a 50-50 market share situation. China produces approximately 99%, let me repeat that, 99% of the world's heavy rare earth metals.
The dysprosium, the terbium, the heat-resistant ones.
Exactly. And almost as importantly, they also produce around 90% of the actual high-performance magnets manufactured from those materials. They control the mine and the factory.
How did this happen? Why such a complete monopoly, especially on the heavy REMs? Was this like a deliberate strategy by the West to let this happen?
It wasn't deliberate in the sense of consciously handing over control, but it was a predictable outcome of, let's call it strategic economic short-sightedness, mainly driven by environmental concerns and costs.
Explain that.
Mining, and especially processing rare earth elements, is a notoriously dirty business. It involves using pretty hazardous acids like hydrofluoric acid, and it generates significant toxic and sometimes radioactive waste.
Not something you want in your backyard.
Exactly. Starting back in the late 80s, early 90s, Western nations, including the U.S., faced increasingly stringent environmental regulations and much higher labor costs. So they effectively, consciously or not, outsourced this dirty part of the supply chain.
To China.
To China, where regulations were much looser, costs were far lower, and there was a willingness to take on the environmental burden in exchange for economic development.
So the West basically traded strategic self-sufficiency in these critical materials for cleaner air and cheaper manufacturing costs elsewhere.
That's a blunt way to put it, but yes, essentially. The low costs coming out of China made it impossible for most Western producers to compete. Mines closed, refineries shut down.
And now there are no real alternatives.
Very few, especially for the heavy REMs and the magnet production. The sources mention the only other notable competitor, a refinery in Vietnam, actually halted production just last year, 2024, apparently due to tax disputes.
Leaving the field pretty much entirely to Beijing.
They essentially inherited, or rather strategically built and then consolidated, a near monopoly on some of the world's most critical high-tech inputs.
Okay, but what about the U.S. fighting back? We hear about the Mountain Pass mine in California. That sounds promising, right? Surely that's the answer.
It's part of a potential long-term answer, but it's far from an immediate fix.
Yeah.
Mountain Pass is the only significant REM mine operating in the U.S. right now. But there's a critical distinction here. A mine produces ore, raw rock. It doesn't automatically refine that ore into the separated, high-purity, individual rare earth oxides, nor does it manufacture the final, complex magnets.
So there are multiple steps involved.
Many steps. And Mountain Pass, while it's ramping up, is only, as the sources say, barely begun, the first stages of building out actual commercial magnet production capabilities. They expect to start supplying some magnets, perhaps to companies like General Motors for EVs, maybe by the end of this year.
So the U.S. can dig the dirt out of the ground,
right,
but lacks the scaled-up capacity to fully process it into the high-spec components needed for, say, defense applications.
Precisely. Building that downstream capacity, the complex chemical separation plants, the specialized magnet manufacturing facilities, that's a massive undertaking. It takes years, multi-billion-dollar investments, and specialized expertise that the U.S. largely lost when the industry moved offshore.
Or we're decades behind, essentially.
In terms of integrated scaled production, yes. The timeline to rebuild that is far too slow to absorb a sudden, immediate supply shock from China today.
And compounding that vulnerability is the cost. You mentioned these materials are expensive. The sources note dysprosium oxide is over $204 per kilogram inside China and presumably much higher outside.
Right. It reflects the difficulty of separating these elements. They often occur together, and the relative scarcity of the heavy ones like dysprosium. Because they're so expensive, companies don't want to hold large inventories.
They use just-in-time delivery.
Exactly. Standard practice in modern manufacturing. Keep inventory lean to control costs. But that means there's very little buffer.
So if supplies are interrupted,
the sources warn that even a short interruption, a depletion of existing stocks, could immediately threaten to shut down car factories in Detroit making EVs. It could halt production lines for advanced electronics. And it poses a direct, dire risk to U.S. defense industries.
Because they simply can't get these specific high-performance magnets anywhere else quickly.
Not at the scale or specification needed, no.
Okay, so the vulnerability is clearly high. But China isn't just slamming the door shut with an outright ban, are they? They're using a more subtle tactic, described as regulatory choking. Sounds bureaucratic, but the sources imply it's designed for maximum pain. How does that work?
It's actually quite sophisticated and arguably potentially more effective in the long run than a simple ban. A ban might trigger a massive global crash program to build alternatives.
Whereas choking?
Choking uses bureaucracy as a weapon. China is imposing a new, much stricter export licensing system specifically for these rare earth magnets. And they've intentionally built in significant delays and uncertainty.
What kind of delays are we talking about?
Under these new regulations, getting approval for an export license is expected to take up to 45 working days.
45 working days. It's what, 9 calendar weeks? Almost 2 months?
Exactly. For materials that companies usually rely on getting shipped almost immediately under just-in-time systems, for a manufacturer waiting on critical components, a potential 2-month delay is an eternity. It's the economic equivalent of, well, suffocating.
It creates instant suffocating anxiety, as the source puts it.
Precisely. It immediately disrupts production planning. It threatens prolonged supply chain interruptions. And it achieves this without an official ban, just by weaponizing red tape.
And the suspicion is that this isn't just about delays, right? The system could be used for permanent exclusion.
That's the long-term fear, yes. The system is anticipated to allow Beijing to permanently block exports to specific end users or companies, particularly, you'd suspect, U.S. military contractors or their suppliers, perhaps citing vague national security reviews, surgical denial under the cover of regulation.
Economic analyst Renee Swarth calls this an unprecedented escalation.
She notes, and I think it's right, that we've moved decisively past the phase of tariff confrontations. This is a fundamental battle now over strategic resources, where one player, China, controls not just the raw material, but the entire sophisticated production chain needed to turn it into a usable, critical component.
The stakes are incredibly high.
Yeah.
It's about who dictates the future of military and technological power.
And the critical takeaway here seems to be that building viable alternative supply chains, the mines, the refineries, and the magnet factories, is likely a decade-long project, maybe longer.
And in the meantime?
In the meantime, China holds the keys, and they seem prepared to use bureaucratic friction, regulatory choking, as a powerful tool of economic coercion.
Okay, let's pivot now. From the high-tech, clearly strategic world of rare earth metals to something completely different, yet potentially even more devastating. The silent weapon, heparin.
Yeah, this one is. It's almost unnerving because it's so mundane, so hidden in plain sight.
Heparin. It's an anticoagulant drug, a blood thinner. How can something like that be a geopolitical weapon?
It sounds almost absurd, I know. But the reality, according to our sources, is chillingly simple. If the supply of heparin were suddenly drastically reduced or cut off, major surgical procedures, particularly heart surgeries, could effectively cease in many hospitals around the world. Kidney dialysis centers could be crippled. Hearts could literally stop in the world's most advanced hospitals simply due to the lack of this one common drug.
That's a shocking claim.
Yeah.
We're not talking about some niche cancer drug here.
Not at all. This isn't just about pharmaceuticals in the abstract. It's about dependence on a life support system component.
Okay, put this into perspective for us.
Yeah.
Why is heparin so critical? What's it used for?
Heparin is one of the oldest, most famous, and most essential anticoagulants we have. It prevents blood from clotting.
And that's needed when?
It's used literally every single day in thousands upon thousands of procedures globally. Think open heart surgery, you need it for the heart-lung bypass machine. Think placing coronary stents. Think kidney dialysis patients must have heparin circulating with their blood when it goes through the dialysis machine, otherwise it clots instantly. It's also used to treat existing blood clots like deep vein thrombosis, DVT, or pulmonary embolism. Basically, no advanced healthcare system, as we know it today, could function normally for more than maybe a few days without a reliable, steady supply of heparin.
And what's the scale of U.S. reliance specifically on this one drug?
The numbers are staggering. One source estimates that 12 million patients in the U.S. alone rely on heparin-based products every single year.
12 million.
12 million. This isn't a minor medication. This is like the oxygen mask for a huge chunk of the advanced medical system. If it disappears, the system suffocates.
Now let's get to the really crucial part. Where does heparin come from? Because this is the heart of the vulnerability, isn't it? It's not synthesized in a lab like many modern drugs.
Correct. And this is where it gets, well, unexpected. Heparin is produced from a biological source, specifically the mucosal lining of pig intestines.
Pig intestines,
Seriously. That's the primary source globally for the raw material needed to make pharmaceutical-grade heparin.
And this biological sourcing, that's where the economic reality, the vulnerability comes in.
Absolutely, because it's an incredibly resource-intensive and labor-intensive process. You need two things in massive quantities: pigs, millions of them, and the low-cost specialized labor needed to harvest and perform the initial processing of that intestinal material.
Can you give us a sense of the scale? How many pigs are we talking about?
The numbers are mind-boggling. To produce just 1 kilogram of the raw active pharmaceutical ingredient, the heparin API,
Just 1 kilo.
requires processing the entrails, the guts of over 3,000 pigs.
3,000 pigs for 1 kilogram of the active ingredient.
Yes. So think about the global demand for heparin daily. You need guaranteed, continuous access to millions upon millions of pigs, and you need the infrastructure and workforce capable of handling this enormous volume of, frankly, animal byproducts. It's an industrial-scale biological harvesting and rendering operation.
It's not a clean, high-tech chemical synthesis plant.
Not at all. And we don't actually have to imagine what happens if this supply chain gets compromised. There was a major crisis back in 2007 that serves as a really stark warning.
Right, the anecdote in the sources. Tell us about that.
It was a horrifying event, and honestly, a warning that the world seems to have largely ignored or at least didn't act upon sufficiently. In 2007, U.S. pig prices had risen, putting cost pressure on Chinese suppliers.
Okay.
So, some unscrupulous Chinese factories trying to cut costs intentionally adulterated the raw heparin ingredient they were exporting.
Adulterated with what?
They mixed it with a cheaper, chemically similar compound, oversulfated chondroitin sulfate, I believe, which was extremely difficult to detect using the standard quality control tests at the time. It mimicked heparin in some tests, but had dangerous biological effects.
And what happened when this contaminated heparin reached U.S. hospitals?
It was a disaster. The adulterated drug caused dozens of patient deaths and hundreds, possibly thousands, of severe adverse reactions, allergic reactions, dangerously low blood pressure, other unexplained side effects. Patients were harmed directly because the supply chain failed, catastrophically.
A complete breakdown in quality control and safety.
Yes. But here's the kicker. Despite this massive health scare, despite the deaths and injuries, the U.S. essentially had to continue importing heparin from China.
Why? After something like that?
Because there was, and still is today, no viable, large-scale alternative supply chain ready to take over. There wasn't and isn't enough synthetic heparin capacity or production from other biological sources, like beef lung, which used to be a source but has prion disease risks, to meet the demand. The dependency was already absolute, even back then.
It's incredible. Even after a deadly contamination, the reliance was too great to switch.
It highlights the depth of the vulnerability, which brings us to China's dominance today. The sources are unambiguous. China is by far the world's largest producer and exporter of the raw active heparin material.
The API, the basic ingredient.
Exactly. This raw material is then often shipped to pharmaceutical plants in the U.S. or Europe simply for final purification, formulation into doses, and packaging. But the critical choke point, the source material, is overwhelmingly Chinese.
What percentage are we talking about? How much does the U.S. rely on China for heparin?
The figures cited suggest the U.S. depends on China for over 90%, 90